Hey everyone, welcome back to my channel EduVibe. Today we will start with the next topic or the last topic of the system of equations and inequalities, which are the linear and the quadratic inequalities. In the previous video, we will more focus on the systems of the equations and the inequalities. We're using the two methods where the graphically and the algebraically. In algebraically, we will do elimination and the substitution method to solve the inequalities or the equations of inequalities. But in today's we are more focused on the inequalities. So what are inequalities and how that inequalities impact on linear and the quadratic. There are two types of inequalities we have to discuss today, and the questions we also discuss. So this is a more type of the graphs question we have to discuss in both. So let's move on to the knowledge first. This is the knowledge you have to understand in this. So firstly we're doing the linear inequalities in two variables. So this one, you all know this is the standard we can say standard function, where we can see that this is for the graphs. When we make the graphs, so the graph look like this type of equation. So this type of solution is called the slope y intercept form. So this is the slope y-intercept form, where we have y-intercept and more the slope. So this m denotes us the represents the slope of the line, and that b is the y-intercept. So that's how it's called the slope y-intercept form. So in inequalities, if we talk about the inequalities, so this is equal to sign change to the inequality. So there are four types of inequalities. So first one is the greater than. We all know that. These all know we know. So greater than, less than, greater than or equal to, or less than or equal to. These four we know, and these four we use in linear inequalities and the quadratic inequalities with the same type of form. So if we're talking about this equation, we have this inequality 3x plus 5 is greater than or equal to 17. So what does this means? So this means that this one is greater than or equal to this 17. If we evaluate this if we solve this, so this 3s equality remains this, and the 17 plus 5 goes over there, become minus 5. So the 3s greater than equal to 12. So that s greater than equal to 12 by 3, where we get 4. So from here we get that x is greater than equal to 4. So if it is made on the number line, so this is your number line, you all know that this is the 0 and we have 4. So 1, 2, 3, 4. We have minus 1, minus 2, minus 3, minus 4. And this is the greater than equal to 4. So this means that 4 we made the solid dot. You all know that if this included, if some number is included, so we put the dark circle. If not, we put like a blank circle like this. So this means that 4 and greater than equal to, so this all thing be included till infinity. So that's why in the number line we note x greater than 4. And what about this as less than minus 2? So on the same number line, if we made that this is the minus 2, so minus 2, this is not included. So we made the round type of thing, and this goes to over there till minus infinity. So that's how on the number line we have to denote the things. But if we talk about in two variables now, this is a single variable. We have only x over there. We have only x over there. But if we on the two variables now, so here's the thing which then only changed some things, not the type of inequality, but in two variables there is some different aspect to be known. So the linear inequality in two variables may be one of the following forms. So there are two following forms. First one is a solid line or a dashed line. Solid line means we just made that line like this, and the dashed line, you all know that this is a dashed line. So in the solid line, included in the solution region, if the inequality is less than equal to or greater than equal to. If we given any inequality or a linear equality, if we given, so if that linear equality is greater than or equal to or less than or equal to, so this means that we have to make the solid line on the graph. So how we can make that solid line, how can we make that type of graph, we discuss example later. So in dashed line there is an inverse, so not included in the solution region if the inequality includes this. So if it is less than or the greater than, so we make the dashed line. How? We will discuss. And you all know that we have a test point. We know that we have a test point in the graph which is x comma y. That point that is used to determine the points in the region satisfy the inequality. We satisfy the inequality, and the test point cannot be on the boundary. They cannot be on the boundary. They should be on the center. In that case, we have the test point of 0 comma 0. This is the region also, and this is the test point too in any graph. So let's know more about the linear inequalities. How can we make the graphs if we have in two variables? So we have four graphs, four kind of graphs we make. So the first thing, if we know that this graph, if it says y is equal to ms plus b, it is that kind of graph. So we have to rewrite the inequality into the slope y-intercept form. If it is not in this, so we have to rewrite this. So that y is itself on the left side. So y should be on the left side and is equal to all the inequality we have. Here's the important that we all know that if you multiply or divide by a negative number, when you shift it, when you isolate the y on the left side, and when you multiply or divide by doing this by a negative number, so the inequality sign switches the direction. So this means if we do anything like minus 3x is equal to 12 plus y. So when you do this kind of thing, so you divide this negative over there. So when the negative divides over there, that if this is greater than equal to this, so this reverse sign goes over there when you divide this. Graph the line, shade the appropriate region based on the following guidelines. So what are the guidelines? So first one is y is less than ms plus b. So if it is less than ms plus b, so if this is not like an equation, we just know that how can we make if we have that type of inequality. So in this thing, dimension we have a dashed line and shaded below. This is the thing if we have a less than, y is less than we have. So how can we make, like I made this dash line random, and if it is less than, so we have to shade it below, and we have a dash line. So I made the dash line and we are shaded below. So shaded below means we have to shade this part. This all parts should be shaded if we have a less than. Y is less than this. If we have less than equal to, so if we have less than equal to ms plus b, so we have to make the solid line or the dash shaded below. So solid line, if we make like this now, if we made like this dashed solid line, so this means we have to shade it below again. So this one now. So this all parts should be shaded if there's a type of thing. In the less than one, we always have shaded below. But if we have greater than ms plus b or greater or equal to, if it is only greater than, so we have to make dash line and shaded above, and if it is greater than or equal to, so solid line and dash above. So make this graph together now. We have this line like over there, and we have a solid line like this. So in that case, we have to shade it above. So this thing has to be shaded. This one. So this can be shaded, and in this question we have to shade it. Now this is the below. This is the below, and this is the above. So I have to move the and see what is below and what is above. So that's how you can make the graphs of different types and inequalities. We have to shade the regions in this. So let's move on to the example now. In this, we have to make the graph of 2x plus 3y, which is less than equal to 6. Determine if the point minus 2 comma 4 is part of the solution or not. So we have the inequality, but firstly we have to isolate the y in this. First step is isolate the y and make this equation in y is equal to mx plus b. And this equal to sign is replaced by this inequality. So firstly 3y is less than equal to 6 minus 2x. Now that y less than equal to minus 2x plus, say I just move this minus over there and divide this by 3. When we divide this by 3, so minus 2x by 3 plus, so this makes like this, and this one goes like this, so we get that only 2. So we get our inequality in ms plus b form. This is a linear inequality. So now we have to make the graph from here. So how can we make this? This is in b form, so this is our y-intercept. So the y-intercept should be on the graph. So this might be over there somewhere. So this 2, and we have a slope of 2 by 3. So that 2 by 3 slope means we have some, this is like the random thing we have to make. If you have like a lines on the graph, so this is more accurate. But this is like the random points. But if you want a table of values, so you take y and put the y values and get the x values. So this is random and we have a 2/3 of slope, so it's a minus. So we have to make like 2/3 of slope right over there. Some random points we have to make just to make the line. Now this is the less than equal to, so we have a solid line in this. So we just join this now in the points, and we made that of a solid line. And now this is the less than equal to, so this means this is shaded below. So this whole thing it should be shaded. The whole thing is shaded now, so this is the thing we have to just make. So now you have to just put this point on this equation and see that if this point lies on this graph or not. So now you have to put like y is equal to 4 minus x is equal to minus 2 upon 3 plus 2. So we get minus that plus 4 by 3 plus 2, and you have to take the common denominator. So 3, 4 plus 6, so we get 10 by 3. So the 10 by 3 is like 3.33 something, and that 4 is greater than equal to 3.3. So 4 is right over there somewhere, and this is less than and equal to 3.3, and that point minus 2 minus 4 is lie on the graph or not, so we have to make that point. So minus 2 some over there and 4 some over there, so this might be on the graph somewhere. This is not the accurate graph, it might be on somewhere. So that's how you have to make the graphs and linear inequality, especially in two variables. We are on the quadratic inequality, so this is the same thing we have to discuss in this too. If you can express a quadratic inequality in two variables in one of the following forms, so they are the same things we have to think. If we have less than, so shaded below, and dotted curve. In this we have to make the parabolas. So either we have like that dotted curved, or we have a straight curves like this. So that's how just curves we have in this. If we are less than equal to, so shaded below and solid curve, and if it is greater than, so shaded above and dotted curve, is greater than equal to the shaded above and solid curve. Remember that a, b, c are real numbers, and a should not be equal to 0. There should always be greater than 0, either the less than 0. So in quadratic inequality, into variable represents the region of the Cartesian plane with the parabola as a boundary. So the graph of a quadratic inequality is the set of points x, y that are the solutions onto the inequality. So this is not the only thing we have to know. Like in this, we have to make the dotted curve or the solid curve. The rest of thing also always like the same as linear. Now we just have like this type of standard equation when we deal with the quadratics. You all know that there is a highest degree of 2 in quadratics. So let's discuss the example. So it says that x is less than minus 2x minus 3 square plus 1. Determine if the point this 2 to minus 4 is solution to the inequality or not. So for this, we again put the x values in and get the y values. So like I show you that how can we make that we did x and y. If we had to put x is equal to 3, that x is equal to 3 if I put, so I get y value of 1. If I put x is equal to 4, so I get minus 1. If I get 5, put x is equal to 5, I get y value of something minus 7. From here, we also know that our vertex is what? So it's 3, 1. So that 3, 1 should be made first. If we have 3 right over there somewhere and we have 1 over there, so this is 3, 1. And we have to make this points plotted in this. So 3, 1 already plot. Another is 4, minus 1. So it's somewhere over there. And we have 5, minus 7. So this. So this over there. So we just made the random points now to make the parabola. So as you can see that this A is our in minus. So A is minus, so it opens downwards. So we have to make this downwards, and this is like less than, so we have to make the dashed line, which is that type of lines we have to make by joining those points. So in this we have to shade it where? So we have to shade it below because this is less than and we have only less than, so this part should be shaded. So this is the above and this one is our below region, above region. This is our above region and we have to like shade this. Now we have to know that this is the point on the graph or not, that 2, minus 4. So 2 right over there somewhere and minus 4 is somewhere over there. So this point might be over somewhere there. So this point is over on the graph, which is 2, minus 4. So yes, this point is on the inequality of this. So that's how you have to make the quadratic equation graph. This is more likely the easy type of thing in this one. For this lesson, I hope you are understanding that how can we make the graphs. If still you have any questions, let me in the comment section. So this is very small unit, inequalities. So we completed with this unit with only 2 lessons. In the next lesson, we will start with the trigonometry of grade 11. So that trigonometry is like we do in the introduction to ratios, and we do more the trigonometry in this. And so that trigonometry is like a basis of the grade 12th math, grade 12 trigonometry. So in the next we will start this. So learning may simple EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. So see you in the next lesson. Till then, stay connected with EduVibe.